Chapter 1.8, Composition of Functions. Our goals for the chapter are to add, subtract, multiply, and divide functions. Find the composition of one function with another function. So the sum, difference, product, and quotient of functions. Let f and g be two functions with overlapping domains. Then for all x common to both domains, the sum, difference, product, and quotient of f and g are defined as follows. So we notice the sum. If you have f plus g, you just add f of x plus g of x. The difference, you have f minus g, which is f of x minus g of x. The product, you have f times g of x, so that's f of x times g of x. And the quotient, you have f over g of x, so you write f of x over g of x. And remember, the denominator cannot equal 0. So let's find the sum of two functions. Given f of x equals 2x plus 1 and g of x equals x squared plus 2x minus 1, find f plus g of x. Then evaluate the sum when x is 3. So let's write f of x plus g of x. And so that's going to be 2x plus 1 plus x squared plus 2x minus 1. So we just combine like terms. We have x squared plus 4x, and that's all we have. Then it asks us to find about the sum when x is 3. So f plus g of 3 is 3 squared plus 4 times 3, which is 9 plus 12, which is 21. So try out this example down here. Given f of x equals x squared and g of x equals 1 minus x, find f plus g of x. Then evaluate the sum when x equals 2. So pause the video and try this out. So if you tried this out, you should have gotten x squared minus x plus 1, and f plus g, when it's 2, is 3. So let's subtract. Finding the difference of two functions. Given f of x equals 2x plus 1 and g of x equals x squared plus 2x minus 1, find f minus g of x. Then evaluate the difference when x is 2. So we're going to take f of x minus g of x. So that will be 2x plus 1 minus x squared plus 2x minus 1. So that becomes 2x plus 1 minus x squared minus 2x and a plus 1. So to make sure that you distribute the negative throughout. So then you get negative x squared plus 2. Then to find out what f plus g of 2 is, then that's negative 2 squared plus 2. So that is 4 plus 2, which is negative 4 plus 2, which is negative 2. So go ahead and try this next example. Given f of x equals x squared and g of x is 1 minus x, find f minus g of x. Then evaluate the difference when x is 3. If you tried this out, you should have gotten x squared plus x minus 1, and f minus g of 3 is 11. Now let's try multiplying the two functions. Given f of x equals x squared and g of x equals x minus 3, find f times g of x, then evaluate the product when x is 4. So we're going to take f of x, and we're going to multiply it to g of x. So this is x squared times x minus 3, which is x cubed minus 3x squared. Then to find f times g of 4, you plug it in. So this is 4 cubed minus 3 times 4 squared, which is 64 minus 48, and that is 16. So try the next example. Given f of x is x squared and g of x equals 1 minus x, find f times g of x. Then evaluate the product when x is 3. If you tried this out, you would have gotten x squared minus x cubed, and then evaluating the product when x equals 3, you get negative 18. So let's look at the quotient of two functions. Find f over g of x and g over f of x for the functions of f of x equals square root of x and g of x equals square root of 4 minus x squared. Then we have to find the domains of f over g and g over f. Now this is pretty quick, but the hardest part is finding out the domain. So we have to remember when we have square roots or even roots, we have to make sure that it has to be positive inside, 0 or greater than or equal to 0. So, and then in the denominator, we need to remember that that cannot equal 0. So lots of things to think about in this type of problem. So let's do the first one, f over g of x. So we have square root of x, that's our f of x, and then g of x, we have square root of 4 minus x squared. So let's think about our domain first for each piece. So in the numerator, we know that x has to be greater than 0, or we can say that it's 0 to infinity. Then in the denominator, so we have to think about, what restrictions we have here. And we know that x has to be between -2 and 2, right? If I plug in anything less than -2, like -3, for example, that would be 4 minus 9, which you can't have in the denominator. So you just have to think about what the restrictions are there. So in interval notation, that is going to be parentheses -2 to 2, and also parentheses. It's parentheses because you cannot have 0 in the denominator. So you have to make sure that that is parentheses there. So let's talk about our domain over the entire function of f over g of x. Okay, domain of f over g. That is going to be lowest value that we can have is 0, and that'll be a bracket because 0 in the numerator is fine, but the highest it could go is 2. So our domain for f over g is 0 over 0 to 2. So let's try the next example. Let's do square root of 4 minus x squared. This is g over f, and our f is square root of x. Now the domain is the same. So the domain for the denominator is going to be 0 to infinity. And this time we can't have 0 included, so it's a parentheses. In the numerator, we can have -2 to +2. So those are brackets in the numerator because you're allowed to have 0 in the numerator. Now let's talk about the domain over the domain of g over f. So the lowest value we can plug in that this will work is 0, or we have to plug in something larger than 0 actually. So it starts from 0, and then the highest value we can have is 2, and we can include that, so it's 2 bracket. So go ahead and try this example here. Find f over g of x and g over f of x for the following functions. F of x is x minus 3, g of x equals 16 minus x squared. Then find the domains of f over g and g over f. So pause the video and try this out. So if you tried this out, you should have gotten x minus 3, square root of x minus 3 over square root of x 16 minus x squared. The domain of f over g is going to be 3 bracket because you have 3 in the numerator, but the highest it can be is 4 or just below 4, right? This is not included. Then it flips, it's the same for g over f, but the domain changes just a little bit. We know that we cannot have 3 in the denominator because it makes it 0, so it's a parentheses. And then in the numerator, the highest it can be is 4. So this is our domain. Thanks for watching.